I assume it's recording. Okay, so now let's share the screen. So I have this, oh, no, here. All right, so everyone now it's recording, right? So follow along, please. So the idea, as I said, is you can navigate. I think I have the GitHub open already. We're not going to need Brightspace today, I don't think. So basically, as you know, we are in the PyTorch repo, and now go to basics. So last week we completed basically these scripts: Scratch Learning, Jupyter, Scratch Learning PY, and SGD Scratch Learning. So we finished. They're pretty much all versions of the same thing. And so we did an example at work, right? So we were able to predict Fahrenheit from Celsius. So now, today, I'm going to go over, and we've also completed basics torch, which was basically just doing tensor operations, very similar to how you did NumPy operations. So now what we have left is create adversarial images. All right, and we're going to be playing with some cat images because it's fun, right? And we're also going to do read data to PyTorch, okay? So here I have several examples of how to read in data. Think like images and regression data, right? The two main ones. The one that's a little bit harder is if we have text data, right? So how do we read in text data? So that's a little bit more challenging. And so we're going to hold off on that. Obviously, as we get towards the end of the semester, right, you know, we're heading in that direction. So it's almost like we start with regression and images, and you end up in like natural language processing kind of thing. We're not, I don't think we're going to do speech this semester. It requires too much signal processing background, but those three mediums for sure, okay? Which should capture pretty much regression, images, and text captures quite a bit of things that you can do in machine learning. All right, so we need to download, so this is recording. We need to download the repo, right? So to do that, you need to go to PyTorch, and you need to download the whole thing. I don't know that I've downloaded it, so make sure, you know, I'm downloading it because I want that zip file in there. So that should be that. Go to downloads. Okay, and then it's this one. And then extract all. Right, so this is what you should do, right? So follow along or make sure you pay attention. All right, and then in here, really, you know, I'm going to go to basics, and what I need is data.zip. So I'm going to control copy. Now, I believe on the desktop, we've created a folder for this class, 520, and you guys are session 2. All right, so I'm going to add it in there. Okay, so that's the data that we're going to play with, okay? I've created this data just so that it's easy for you guys to begin, but keep in mind in the future, I'm not always going to give you the data sets, right? I'm just going to give you links or say, go get this data set, and it's not a trivial thing dealing with data, okay? So be aware of that. Go ahead and extract the data here. All right, and I'm just going to go over here. So now I've got my data. Double click on data, and you can see I have several things, right? So I have wine quality, wide CSV, right? So that's going to be, I believe it's regression data, if I remember correctly, or it might be a ranking, actually. So it presents some interesting challenges, right? And ideas to think about. There is a Bobby. That's a picture of a dog. Yeah, a dog, right? So we've got an image of a dog, and obviously, you know, machine learning processes dogs and things like that. I do have some text in here, I believe, in this one. So yeah, it's a story, Pride and Prejudice. So it's a bit more challenging. I mean, it's easy to read text into tensors. Now, reading text into tensors efficiently and effectively is a different story, right? So that's a completely different story, and it requires quite a bit of work, right? That's not so trivial. And then I have this image of some cats also, and we're going to play with that as well. All right, so that's kind of the first part of this. This discussion is really just talking about reading in our data into our models, right? Into really, Python and PyTorch and everything. All right, so let's go ahead and begin. So obviously we need the environment. So I'm gonna invoke the way I usually start it, right? So I'm gonna go ahead and go to Anaconda prompt, which is how I like to start. I have my data ready to go, right? And I'm just gonna navigate. I put it in the folder, that's the appropriate folder, right? And so I need to navigate into it. So I'm gonna do dir, right? And then I'm gonna cd into desktop, dir, cd into its, nope. ITS 520. Okay. And then this is session 2. Okay. So go in there, CLS. All right, clear it out, dir. And now I've got my data in there, right? So we can take a look at the data, although we don't need to write the scripts in there. So if I use dir, and it's okay, so there's another one. So don't forget that there's 2 levels. Okay, and then now I have my files in there. So I've got Bobby that we just saw. We've got images of cats, wine quality, CSV, and so on, right? So this is going to be, once we're past this and we're past the playing with the images script, we're going to start a project. So it's kind of like how I do these mini projects, right? So really, we could do a regression mini project, then we would do a classification mini project, then we could do a CNNs mini project, GANs, and transformers, right? So it's like 5 mini projects, right? In a perfect world, right? With tons of time. So we may not get to all of those, but that's kind of, the idea. So that's what we're going to be doing. So I'm going to go, just remember this structure, right? Of where it's data, so that we can find our file. So that's an important one. Go back now, dir. Okay. So this should be a good level. All right. So now what is the next part? We need to invoke the environments, Conda environment list, right? So don't forget about this one. And we're going to start the environment for the class. We're going to need to install some new libraries today because we're going to be playing with images. And there's quite a few ways of playing with images, like PIL, which is a native Python image processing tool, or image.io, etc. Right? So Torch also there's Torch Vision. So tons of ways of doing things. We will, in the future, probably, we will use pandas as well. There's multiple ways, so don't worry. But eventually, we'll probably settle on pandas as a good way of reading some of the data, right? Possibly more of like the CSV type of data. All right, so let's go ahead. Conda activate Pi 37 ITS 520 2, right? So you guys are 2. So Pi 37 ITS 520 section number 2, right? So that's my environment, and now I can just boot up Jupyter Notebook if I'm not forgetting anything. Jupyter Notebook, and we are going to start trying to read in some of that data. Okay, so that's kind of the idea. So we'll probably start with now I'll be playing. So the idea when we read images and things is we need to load them into tensors, all right? So that's kind of where we are. We're still not going to be building a model just yet with images, but we will soon enough. We'll start getting there, okay? And, you know, keep in mind your homework assignments are going to start to get more intense. All right, so we are in the environment. There's the data here, so we have it available. So let's start a new Jupyter notebook. So, all right, good. So we have this one. Let's give it a name. So I'm going to rename it. Read in data. So read data from files. Read data from files. Everyone with me? All right, so let's add a few more cells here. Okay, so let's see. Let's import Torch, NumPy, SMP, import OS, which will be useful because, you know, we're looking at files in the directory, right? So whenever we're looking at the file structure, etc., it's good to use, you know, OS can be useful. Now there's a new library here, import image IO. All right, so that's a new library. It's just one example of something that we can use. Now, obviously, this one hasn't been installed, so we're going to try it out. So let's go ahead and hit run. It's going to error out because it's not available. So one thing, you know, I'm anticipating it's not available there. All right, so let's move them over here then, as we usually do. And let's see if we can run. Now, the way that I have this in my notes, image IO, I may be able to do a pip install. I may be able to do that. But let's try, I have this command here, conda install image IO. I almost don't want to do it. And I don't know that this will work. But let's try that one. If some of you want to try pip install image IO and see how it goes, let me know. It works well. Perfect. It worked for you. All right. Yeah. So I kind of want to, I'm hoping this doesn't work so I can do the pip install. I just like to keep things in the same installer usually. Let's give it a second. As soon as this is done, we'll be able to start reading in our file. Okay, so let's give it a minute.
My Jupyter didn't even give me an error message. It's already there.
It's already there? Oh.
6.45 version.
Oh, Python?
Yeah.
Python 6? I have 7, I think.
Oh, really?
Yeah.
So
that's good. I mean, I didn't have it. So. Huh?
My notebook, you know. What? No, actually, my notebook is 6.45. My Python 3.97.
Yeah, 9.7. It's high. It's higher than mine.
Oh,
I don't like to use such a high one because then some things may not work. You know. Yeah, but.
But that was September 2021 at 9.7. Was downloaded September 2021.
No, I know. It's just there's some applications at some point that may not.
Yeah.
They may complain with the version, so I'm always.
Gotcha.
I'm currently, let's say, at the 3.7 level.
Oh,
Probably should. I mean, that's what the beauty of Anaconda, right? You can always just switch to another one.
all right.
All right, so it's still thinking there. My computer's a little bit slow. All right, let's just start writing some code. Meanwhile, it decides to finish, okay? So the very first example should be an example of how to read in the Bobby image, right, into an array. So I'm gonna do image array, and then you just import image IO, okay, dot, and then IM read. Okay, so we're gonna do IM read. And then we invoke the file. So the file is located in data / data. And then it should be Bobby.jpg. So this is a JPEG image. Okay. And then once that should load as a NumPy array, I believe. So then we can just go ahead and print image array img arr. And then, you know, one thing that kind of makes sense is just to do dot shape. Okay. So all we want to do is kind of this. In the second script, we'll start like viewing the images and everything like that. In this one, I just want to do, you know, just give some basic functionality of how to load things. Man, so this is taking forever. Let me do pip install that you guys said it worked, right?
For me, it on the yes no prompt.
So pip didn't work?
Conda didn't work because I had it
Oh.
on yes no.
There was a okay.
Yes,
But then you do pip?
no, I just passed the dash yes.
Oh, and it worked?
Yeah.
Let me try pip. So for those of you that already installed it, just go ahead and run that, and it should give you the image, and it should give you the shapes of it, hopefully. All right, so good. Now I'm gonna run image IO, and then I'm going to read in the image, and there it is. All right, so I'm gonna run it again. And it's what, so by that image, so by the shapes, what can you tell me about the image? What would you say about it?
That's the right way to put that.
Huh?
I wouldn't know. Say anything with the pixel value.
Those are it's a tensor, right?
Correct.
Okay. It's 976 by 1334. And it's got 3 channels, which are the R, the G, and the B, right? So that means it's a color image. Okay. Very important. All right. So now, obviously, what we would want to do after we have this is we would want to convert it into a tensor. All right, because remember, this is currently like a NumPy array. We would convert it to a tensor. Okay. So let's kind of go through that motion. As you can see, you played with tensors. Now you have data, an image, and now you're making that image into a tensor and building up from there. And then after that, we're gonna build a batch, right? Which is, what does a batch mean? It means multiple images in a tensor. Got it? So now let's think about this. We want to convert, make image into torch tensor. Okay, so we want to convert the image into a torch tensor. All right. Now, PyTorch has specific requirements, so it's just how they made it. So I'm just going to make this note here. PyTorch, wants images like this. So the images in PyTorch should be channel by height by width. Okay, so if you notice, the channel should be in the front. Now our image, where does it have the channel? In the end. You see that? So it's height, width, channel. And PyTorch wants channel height, width. You see that? So these are like the little things with tensors that it's now becomes really important to understand these tensors or NumPy arrays, etc., and be able to play with them, because you know really you have to do this all the time. But it's very efficient, right? It's super efficient to do this kind of processing. So let's make this a markdown cell. Let's just hit run. So we got some statements there. Now let's go ahead and convert this one into a PyTorch tensor. So I'm going to do img equal, I invoke torch dot. Now you guys remember from NumPy, right? That nothing special is necessary here. This is the beauty, right? You know, you had an image, made it into a NumPy array, boom, it's a tensor. Forget that it's an image or anything like that. Now it's data loaded in these dimensional objects. And that's really what's very important. So we can use the from NumPy function that we did before. And now we're just going to add in here img arr, right? That's the NumPy array. Any questions, guys, back there? Any questions? All right, so now let's go ahead and print this one. All right, so it's going to be print img dot shape, right? So still the same. We've changed it from a NumPy array. Hopefully you can see that into a Torch tensor, but the dimensions are still the same. So it's not like Torch is going to reject this. Torch doesn't care. But when we start loading this into machine learning models to do, you know, there's a certain way that it usually by convention, it expects things to be. So to change this, we're going to use something very interesting, which we've printed the shape, right? And now we have a function built in, and there's a lot of ways of doing this. Again, there's lots of ways of doing things, but let's create another variable out, and we're going to give it img dot, img, which is this one, right? And then we're just going to call something called permute. All right, and this function allows you to very easily change what is what, okay? So you can play with it if you'd like. For our purpose, so the assumption is this is 0, 1, and 2. Do you see that by index? So this is indexing of this tensor. So again, 0, 1, 2. So it needs to, so if this is already height and width, right? But channel needs to be in front. And this is 0, 1, and 2. If you want to permute it, how would you put the order of the indices now? Yeah.
I have a question.
Oh, go ahead.
What is channel?
Channel is, so every image,
Okay.
if it's a black and white image, is only a grid that is 28 by 28, or 30 by 30, or 300 by 300. Or in this case, 976 by 1334.
Okay.
Right? They're black and white. But for us to make an image in a computer that's going to be color, we need actually three versions of that same grid.
Okay.
And those are the channels. One is the R, one is the G, one is the B. So it's the red, blue, and green.
Oh, that makes sense now. Thank you.
Got it?
I guess I already knew that thing.
There you go then.
Thank you.
Good. All right. So yeah, so that's going to be a standard approach. We always have to like take into account the colors, or you're going to lose data, right? Or you can convert from color to black and white. That's something you could always do if you'd like, especially to reduce dimensionality and things like that. Your problem may not require it. Got it? All right. So again, going back to the question here, currently I have what? Height, width, channel, correct? And that's, I'll spell it out, indexing 0, 1, 2. But I want channel height width. So what would be the order of the indices? 2, 0, 1. Very good. And that's what the function allows you to do very nicely, right? So now we can go ahead and print out dot shape. And this is why shape is really great. We don't even have to look at the image, right? We know that these functions work, right? So really, all we care is that it should say now 3,976, 1,334. Okay, so if we hit enter, boom, got it, done. And so that's kind of great. These are the reasons why it's good to understand the NumPy objects, right? Because they give you this flexibility really quickly, right? And some of them are easy. Some of them will be a little bit more challenging. Does that make sense, guys? All right, we're going to do one that's a little bit more challenging now, which is, again, we're still playing with tensors, right? We're just playing with tensors in a slightly more complex way, right, than the previous exercises we've done. And now we've got data. So I have I showed you in data, I have a folder called image dash cats, and that has 3 images of cats, okay? Now, I believe the images are the same size, which is important for this problem. Yeah, the images are actually 256 by 256, I believe. Right. And so that's important, right? Because you're taking an image and you're fitting it into something, okay? So what I'm going to do now is imagine this scenario. I have this image. This is one image. But now I'm going to have 3 images. You see that? And I want to hold all 3 images in a tensor. You get that? So I'm going to create now a tensor called batch. So imagine it's like a Rubik's cube, right? But now I have a bigger cube that contains 3 Rubik's cubes. You see that? In a 4th dimensional. So we can't visualize it because it's 4 dimensions, but it works, right? So that's what we're doing. And this is convenient because, again, what if you want the mean of the 3 images in that batch? You see that? You can calculate that mean as long as you get the dimensions just right. Right? So these are the little tricks that, that we're going to look at. And that's just the nature of how things are. As I said to you guys, this is because of GPUs. When quantum computers are replaced GPUs, then you're going to have to learn this again. This is not necessarily for machine learning. This is for the GPUs, my point. All right. Anyway, so let's go ahead, and for efficiency too, because it works on CPUs also efficiently. All right, so let's go ahead and create, let's think of this tensor that we want to build, right? So remember, so I'm going to create here, I'm going to call this, this is a tensor, but a batch tensor. So this is a batch tensor, okay? And remember, all of this is in the GitHub. All right, so I'm going to do the markdown. So batch tensor. And this tensor needs to hold images that are color images. So already you have 3 by, whatever, by height, by width. And then you need to add a new dimension for the number of those that you hold in there. So let's just since the folder has only 3 images, let's limit it to 3. But this really would work with, how, only RAM is the limit, to be honest. Okay, and your algorithm, etc. So batch size is going to be 3. Now I'm going to create, because we learned in a previous lesson that we can create batch tensors of any kind, right? So I'm going to invoke torch. So I'm going to directly create a torch tensor of zeros for now, and then I'm going to fill it in with data. And so I just need to specify the dimensions for this. And I'm going to say that I want the data type to be int. So int, yeah, because they don't need to be float, right? In fact, they shouldn't be, because it's not normalized yet or anything like that. It's just 0 to 255, right? The scale. So then we're going to say torch dot u int 8, like that. All right, now here comes the hard part. We are going to create a tensor that will hold images, color images, that are 256 by 256, and it should hold 3 of them. So give me the dimensions for this tensor. We're going to specifically define it.
So the order for the early one is, the channel first.
Yep.
Where would you put the number of batch, like?
At the beginning. That's actually what makes sense usually. That's it's because you assume, okay, I have batches in this thing of something. What is it? Who cares? It could be movies, right? And with more dimensions, but what you care initially is how many samples you have in there. So the batch is the first.
So
Batch.
3, 3, then 2, 5, 6, 2, 5, 6.
Yeah, right? Do you guys see that? All right, very good. So since I wrote batch size, this is kind of a good practice to look, to remind yourself. But PyTorch is very nice like this. I like it. If it was TensorFlow, and I'm not saying bad things about TensorFlow, but it'd be a mess completely, right? So I like Torch like this, they try to be consistent. So this is batch size, then channel, right? Then as you said, 256, 256. There you go. This is now, that's my batch. So I created it so we can go ahead and it's a tensor, right? So the next thing you probably want to do is do batch dot shape. Go ahead and run it. And you can see it is a 3, 3, 256, 256. That is perfectly going to hold your 3 color cat images. Okay. Any questions on this one, guys? Again, these are the things that we kind of want to play with and get used to, basically, because we're going to see them a lot. All right, so the next trick that we have to do is now we're going to read the data from memory, right? So this is something you guys will be doing a lot. There will be more challenges because sometimes you'll have classes, right? So if you have classes, for instance, cats, dogs, birds, you need to load cats, dogs later, birds, and associate a label to those things. Right now, we're not doing that. So we're just going to load 3 cat images into this tensor, basically. That's our goal. Okay, so let's go ahead and remember. So I'm going to define a data directory, basically. I can call it that. And I'm going to say, so what was it? Data, and then image cats. Oh, let's add a forward slash here. Yeah. Okay, got it? That's the path so that our cats are there. So now we're the way that you can do this, I like the approach where you have a folder with your images. That's kind of my favorite thing. I like the approach where if you have cats, dogs, and birds, then you'll have a folder for cats, a folder for dogs, a folder for birds. And then as you're reading that folder and the images, you know what they are because you're reading it from that. And the one good approach is to just store like the list of file names or something in a variable. So called, for instance, file names. Okay, so here we go. So I'm going to do a list comprehension. Remember, that's what this is when I do a whole bunch of operations in just a list. All right, so what do we need? Let's think about this one. So we're going to use OS, which is a library that's available in Python. It has something called list directory, list dir, just like that. And then we're going to specify our path, which is data dir. Okay. And now so that should give us basically all the files in there, which there's 3 of them. So we're going to say for name. So, okay. This basically gives me a list. It's like an object. It it connects to the file system at that path, and it looks what's in there, and it's going to see there's 3 pictures of cats. So boom, I got 3 objects, the file path basically. Now I want to iterate through those. So I'm going to say for name in this. Everyone with me? And then usually we would put the next step below the for loop, but in list comprehensions, it goes before so that we can do one-liners. So that's name. And that should be it. Okay. So now, now we can add more things. I don't think we need more things as we only have 3 images in there, but one quick way of knowing is just to hit print file names, right? So we want to see what we've got in there. All right, so let's hit enter. All right, so that looks promising. All right, so I've got my 3 cat images, and I also know where they are because they're in data, image, cat. So with this one and that one, I can now start reading them in, right? I've solved all the problems that I need. Any questions so far? All right, now comes like the magical part, right? We need to take, this just gives me the list of files in there. Now we're going to read all of them into our tensor, right? So remember, our tensor is still empty, or it's zeros basically, but we want to load it with data. All right, so here we're going to have a for loop for. Now file names contains, it's a list, right? That contains those 3 things. So I want to iterate through that and grab those. So what else do I need? I do need an index. So I actually need the index of the file I just grabbed. I want to know if it was the first one, the second one, the third one, and I want to know the file itself. So there's a nice little trick for this called enumerate. And so when you do enumerate of a list, it gives you 2 things. It returns the index and also the thing in it. So then we can do I, comma, file name in enumerate. Oops. Does that make sense, guys? All right, great. So yeah, so we are enumerating from file name. So we're gonna first iteration index 0, cat1.png. Second iteration index 1, cat2.png. Last iteration index 2, cat3.png, and so on. Right, and now we can do quite a bit with this processing efficient. Yeah, go ahead, please.
For I, comma, file name, is that names or name? Because
this is file names because
your,
it's this list,
right?
And I'm gonna iterate through it.
So the file name is just
it's another variable.
Oh, I see.
Because remember, I have 3 files in the list, but I'm going to use a for loop to iterate through all 3 individually. So it's like for file name in file names. And I'm grabbing the first one, the second one, the third one. Yep. Any other questions, guys? All right. So usually at this time, I like to print things. So I just, if I know, it'll work, but I usually like to print things. All right. So now what do we need to do? What do we need to do? So I got all the information I want, right? And I want to load the data into the batch tensor. So what's the next step? You just read the image. You got everything that you need to read the image. How do we read an image? Image IO, right? So we just did an example with that. So I'm going to do image IO dot IAMRead. IAMRead. And we need, oops, sorry. So here, again, you can do this in several ways. There's like a lot of ways, actually. You can just concatenate the strings and that'll work, right? But, you know, a fancy way is to do OS path dot join. I mean, it's pretty fancy, right? But we could have just done this with concatenation. So we got the path where everything is, that's data dir, comma, and then file name. Is this clear, guys? So we're saying what? Data, image cats, cat1 PNG. The next iteration, data, image cats, cat2 PNG. Next iteration, data, image cats, cat3 PNG, and so on. Okay, now we can read the file and we're going to read it into image R. So now at this point, I do want to print, actually, make sure I have something in there. So I'm going to do print, and then we'll get rid of the print. Image R, again, you don't have to print the thing, just print the shape. That should be enough. So go ahead and run this one. What do you guys think? 256 by 256 by 3. That's our images. Looks fine. But they're not permuted, right? And Torch expects it to be permuted. Also, the tensor that we created for this is already set up like that. So that's the only thing with like PyTorch and TensorFlow and these NumPy, even in these kinds of frameworks, you got to get the dimensions correct. And there is no, you know, there's no, well, I mean, I guess nowadays there are some things that help you, but in general, this is the thing where you have to do it and make sure it's correct, okay? Getting the dimensions right. So I just read the image. What do I do now? I'm gonna comment this one out. Okay, so now what? We just did this, right? Image R is what currently? NumPy, very good. So we want to make it now, the permute works with what? It's a function of Torch. So we first have to convert into NumPy, then permute it. Yep. So that's kind of how it is. It's just like it dictates what we need to do next, right? Because this is how it works. So let's go ahead now. I'm going to go into that convention of putting the little T there. That's Torch, right? And I'm just going to do Torch dot from NumPy, just like we did before. And then image R, right? So now image underscore T is definitely a Torch tensor. So we're going to go ahead now and permute it, right? So we can just do image underscore T and then image underscore T dot permute. Just like that. And then we just, we don't even need to change the data type here. We can just say 2, 0, 1. Do you guys agree? All right, that should be it. All right, so let's take a look. Now, what was the data type of these images? They were PNGs. Now, they only had 3 channels. So we should be okay. But just be aware, some images have like a transparency, and like another layer called a transparency. So although it doesn't have anything that visually affects things, sometimes the shape can be a problem. All right, just be aware of that. So I don't think we're going to have that issue, but I'll show you a trick if you did encounter that sometime. All right, so let's go ahead and print this again. So I'm going to do img underscore t dot shape. All right, so now this should be different, and you can see they are now permuted and they are channel height width, and they're getting there, right? Now all we have to do is add them into our Torch tensor. Now, in case you did have more than 3 channels for whatever reason, what could we do? Yeah, we could do the following. So we could try. img underscore t, img underscore t, and obviously I'm going to do some slicing or indexing, right? That's kind of where I'm going with this. Why is this a thing? Because this is one of those areas where sometimes you use torch vision, sometimes you use image IO, sometimes you use pill, sometimes you start using all these different frameworks of how to read in images, and they're not 100% consistent all the time. And then you end up with something that has RGB and something else. Do you see that? It might have it. And so in that case, if you use the right conversion, sometimes like color to black and white or something, it does it for you. But if you don't, you may end up with weird problems, right? And the solution is just to like slice it. All right. So because this is the first level, you know, something like this should be sufficient. Do you see what I'm saying? Does that make sense, guys? Like if you just, it's like you're slicing until then and ignoring the rest. Assuming that transparency would be like after RGB, obviously, which is an assumption. Got it? All right, shouldn't be a problem for us, but something to keep in mind. It's not all perfect all the time. And these are the things that will trip you up when you're doing homework assignments. It's like that somehow it won't work. So remember it if you can. Okay? All right. Now, what else do we need to do? Just add it to, yeah, go ahead.
So, assume that you have like transparency after RGB.
Yeah.
Wouldn't the permute part also be a problem there? So you need to probably address the problem at the permute level. Because it would actually have to forge, or like it would, no, it actually.
Right, I'm just saying if you did have an issue like that, right, you can cut it out.
So in other words, the RGB instead of 3, it's actually 4, right? The last tensor will say 4.
Right, you're right. I mean, but
wouldn't you cut it out only on the last part of the tensor instead of, because
well, the permute only, like this could be 4, right? The permute only moves whatever the value was here to here. Oh, sorry. Where do we have? Yeah, so
yeah.
Whatever value was here, it moved it to here.
Oh, I see.
The permute, because it's only 2.
Oh, I see. So you still leave out.
Permute is only about moving the thing. Nowhere here did we say, if you see it, it's all, this is just reading the file, right? And then here we're just reading it. We don't actually know.
So I guess my question is, so the transparency is not part of the RGB. It's not like.
It might be a 4th one, yeah.
So then the cutting out, when we need to cut the 4th out of this 4 out of, so it becomes 3.
Yeah, so it's, I think when you do 3, it's 0, 1, and 2. It ignores the last one.
Right. So what I'm saying is that you're cutting out a dimension inside the tensor.
Yes, exactly.
But
of the 3rd position. So here it's the 3rd position, which became the 1st position, but that could be a 4, a 5, a 6, a 7, you know, and then we're just cutting it.
Okay, so
slicing it.
Right. So I'm just saying you're not.
Nowhere. So if you look at this code, nowhere, I think what you're doing is you're kind of, because you saw this 3 here, you're kind of assuming that this one is also 3, but nowhere in here do we actually look at it, if you will.
Right.
It could have been a 4.
Right. So wouldn't you then go into that part of the tensor and cut it out, so you only get 3? Because I just didn't know.
We can do it before the permute or after the permute.
Okay.
Look at the steps that happen here, right? Ignore everything else, because nothing really is relevant, right? If you look. So it starts here, folder. Then get the files in it, which are these 3. This could have 3, 4, you know, transparencies and whatnot, right? It could. So then look at what's happening here. We get a list. We can, you know, start reading. We just read the image, and then we just convert it into a NumPy. We don't actually know if it's 256, 256, 4, 256, 256, 3. We haven't checked that or sliced it or anything like that.
No, my point is,
Yeah.
when you're slicing, are you slicing the tensor like 256?
No, I'm only slicing that one,
Yeah, the third
the
part.
RGB. Yes,
Yeah.
exactly.
But how does that line reflect that? Because it's right now it's img that underscore t equals img underscore t, and you're not saying which one am I slicing?
I'm slicing the first one.
Oh, I see.
It's after the permute.
Oh, I see.
You could have also, if you
But-
could also do the other one. Yeah, go ahead.
You put in the explicit version form where you put the comma and then the other colon.
Yeah, so it would be,
It would be, yeah, there would be comma afterwards, like for two more, right? So that's why it's, yeah, I see.
yeah,
So it's saying first one,
yes,
okay.
exactly.
Otherwise, if you use comma and then you do the second one, it's the second one.
Yes,
Okay.
exactly, yes.
That's
Kind of like a shorthand. It's a good, it shows his,
Oh,
teaching skills.
right.
So, yeah, so it's a good teaching, yeah.
okay. So
But yeah, you're right.
it's implied. It's the
It's
first one.
implied. It is like this sometimes. Yeah. Either one, as I said, you can do these things in so many ways, right? But eventually you kind of just like, because it's the first one, you can use that one.
Yeah.
Got it? Yes.
So we use number 3 because we have 3 images. We have 3 sets of 6.
Yes,
Okay.
yes, R, G, and B.
Awesome.
Yes. So if you had, so again, some images for some weird reason that I don't even know will have RGB and then it won't work. And you'll be like breaking your head against the wall for hours until you read somewhere that there's a transparency in there and it's the 4th layer. And you don't need it, it doesn't do anything, slice it out. And it's as easy as something like that. Got it, guys? Any other question? Is a good question. Well, if you didn't like this, I'm going to do something similar and to add to the batch, right? So let's keep it like that. And then now okay. So now I leave it to you guys, right? Add it into the batch. We can also do here, print the shape again, I guess. Might be a good idea. I like printing things out, so that's kind of how I look at things. It still looks the same, right? So nothing. So now, next step, how do I add it to the batch? Well, batch, right? Obviously. Was that the name, batch? Yeah, batch. Okay, it's a tensor. Okay, now where's the image? It's an image T, correct? Is it ready to go? It's a 250, it's a 3 by 256 by 256, but there's only one of it, right? So in this case, IMG T. Now, how do we add it into the batch? How would you? Oh yeah, let me.
Well, if you need 3 channels, is there a way to multiply it by 3? Or am I thinking it wrong?
Think of it as you built a cube and now you're going to fit another cube into it. So this because remember the dimensions of this, right? So 3, 256, 256, right? So what will work here? Where do we, so what's the problem? We don't know where to add it in the batch, right? Because this batch it's like a building with 3 penthouses, right? And each of these images will go into one of these penthouses, to say the least, and they can't all fit in the same penthouse. So then we need to specify which penthouse it should be. Do you guys see that? Indexing, right? Huh? Enumerate? Oh, the index. Very good, right? We have an index, I. Every time we grabbed an image, we knew which one it was, and that was stored in I. Very good, exactly. That's why we had enumerate. Do you guys understand? So now, if everything worked out, let's run it. Okay, no errors. So now how do we can do print batch dot shape, sure. Okay. And that's the dimension that we had. We can print batch 0, right? See what is going to be big. Oh, yeah, that is square bracket there. What do you guys think? Looks about right, right? And so that's kind of the idea. So that's just one of the images loaded in memory. Does that make sense, guys? The tensor. That's why they're called tensors, because they hold so much. Think about what this is holding. This is holding 3 images, which are 256 by 256, and there's 3 channels of them because they're color, RGB. Got it? This is this is the only way that machine learning will work, by being able to manipulate these things efficiently. All right. Any other questions? All right. So again, some of these things become simpler later. Remember, this is more like we're still playing with tensors and getting the mechanics of things. All right. So we've got 16 minutes until the break. So I think we have enough time to do what? Normalization. What's normalization?
Things that are different and making them the same.
Yes, very good. Exactly. So, let's imagine that we have had images, right? And some go from 0 to 255, and others, for whatever reason, go from 0 to 1,000, right? We don't want that, right? We would want all of them to kind of have similar scales, if you will. So it's a scaling type of a technique. And we're going to use this a lot. Machine learning loves normalization or standardization, scaling in general. It really likes things that are centered at 0 and go as far as -1, or as low as -1 and as high as +1. It loves that. Or things in the range of 0 to 1. It learns better. You'll find that immediately when you're doing some problem. If you leave it in the scales that they are, you'll get some performance, and you'll say, like, why isn't it working? And everyone will say, normalize it. And then you'll see an improvement. Okay, it's just a thing of how it works. So we're going to go ahead and normalize our data here. Now, this is a little bit tricky because we're going to take a technique called standardization, right? Which basically we need to calculate the mean and the standard deviation of something, and there's an equation, and normalize the data. But here the problem we have is we need the means and standard deviations of the populations, right? The populations or the samples are for what? The data is in the images, yeah? So you could say, well, I'm gonna take the mean of the image, right? What's the mean value of all the pixels in the image? And use that and the standard deviation. But what's the problem there? You have 3 channels. The question is, should you take the mean of all 3 channels together, or the mean of each individual channel? You see, that's a question to ask. So probably it should be the mean of each channel, right? I mean, it might work out in some situation that just taking the mean of the whole thing was okay, but really they may be different. One is the R's, and the R's, I don't know, the reds are like a specific, very red thing. And the greens actually turn out there's very little green, and so probably do it in different channels. Do you see that? Okay, so we're gonna do that one. Again, this one's a bit tough. so this is more like understanding to play with tensors, okay? All right, so let's do this one, and we have 13 minutes. So we're gonna normalize this. Trying to think. Yeah, so we're gonna do here. We want to take what do we want? We still want the batch, right? The batch should stay the same. So that means it's 3 by 3 by 256 by 256. It should still, we're not changing. That's still there. It's just that the values would not be 0 to 255. They would now be some other range, right? We actually will be able to corroborate that because the values are here, right? All right, so let's think about it. So we want the batch. I'm just kind of like generically writing this right now. So batch would be the same batch, right? But now modified. Now the equation for this is that you usually take, so let me write that actually here. This is the standardization equation, and it's usually should be normalized. So let's say X normalized should be equal to X, the original X, minus the mean, and then this divided. I think this will work. Standard deviation. Let's see if this works. Yep, there it is. So, why is that weird? Oh yeah. All right, so that's basically, and I did it again. All right, so that's basically the formula to normalize. If you look, we've got our X data normalized, right? And in this case, it's understandable. The image is X. Do you guys see that? So the image is X, and then what do? We take the mean value of that X. So we got an image that's 256 by 256. That's all those pixels, right? We want the mean of all of those pixels. Do you get that? But problem that we have is that there are 3 channels, not just one. If it was black and white, then, you know, we'd be done basically. So we need to calculate the mean and the standard deviation of this X image, and then perform this operation, and boom, we've got the normalized version. In the future, I mean, we'll use a function. You know, you give it whatever you want, you'll get the normalized version of it. But for now, let's just play with this idea. Does that make sense, guys? Any questions on this one? So that's the formula, okay? So now we're going to try to write out that slowly. But obviously, this will require, once again, slicing, indexing, those 2 things that you were supposed to practice quite a bit at the beginning of the semester. All right, so then let's add some parentheses here just for to make it better. All right, so I'm trying to replicate this formula here. So batch is the image in this case, right? So I should say the images are in the batch, okay? So now I'm gonna do minus mean, right? Just like before, and then divided by standard deviation. Do you guys see that? Same formula as before. However, what makes this stuff difficult is what? The dimensions, right? Because you have things in tensors, and that's where you have to like finesse this procedure. Now, in this case, we also want, it makes sense, right? You guys tell me, but does it make sense to look at all of the three images, take all the R's or the G's, all the B's, and mean those? So it's like you want the mean of the three images that you want, that you have, but for red, and the mean of the three images that you have, but for green, and the mean that you have for blue. Do you guys see that? So that makes it even harder, right? Because that's, you know, more dimensions for us to play with. Got it? Again, this is challenging, but basically it's just so we can see the power, kind of motivate, if anything, how we can do these kinds of things. All right, so then we're gonna try to work that in. We know for sure. We know for sure that we need a mean and a standard deviation, correct? We know that. So I'm going to have mean here, standard dev here, okay? Kind of like to align them a little. All right, so I have that. Now, I'm going to take those from the batch itself. So that much I know. So I'm going to say batch, and I'm going to say batch. But again, I need to use slicing and indexing to figure this out. So torch, because these are torch tensors, right? I can just use the torch built-in function, standard deviation for this one. And that's going to be like that. And then for this one, it's going to be torch dot mean, which is also from batch. So let me move. Okay, so far it's taking shape, but probably the hardest part still not done. Or you may find it easy, I don't know. All right, so now what else do we need? We need to do this on a per channel basis. That might be the easiest thing to do, right? So we're gonna do it for reds, we're gonna do it for greens, we're gonna do it for blues. Okay, so what do we have? Batch number, channel, height and width, right? So we're talking about the second one, that is the channel, correct? Second one is the channel. All right, so, and there are three channels in there. So how do we, well, let's get n channels. That value can be gotten from batch dot shape. What? 1. Why 1? 0, 1, 2, 3. 0 has the batch number, 1 has the channel. Very good. Very good. Exactly right. All right. So now that we have this, we're going to do it on a per channel basis. There are 3 channels. So for C in range and channels, right? Colon. You guys see that? So we're going to do this 3 times, 1 time for each channel. So 1, 2, 3, 4. Let's add the indentation. 1, 2, 3, 4. 1, 2, 3, 4. Really, all that's left now, believe it or not, is to get the slicing and indexing correctly, and you're done. And we do all of that. Think about everything that we're doing here. We're taking mean standard deviations of all the images per channel and updating the batch, and all with slicing, indexing, and just with 5 lines of code. That's the power of these kinds of frameworks. This is the fastest way of doing it. So now, how do you do it? Slice it and index it. And what do you guys think? So we need to what? We got batch. Okay. We've got this batch, mean and standard deviation. And then we've got this. So maybe the easiest thing to start with is here. How do we calculate the mean of all the reds, the G's and the B's, just one value, right? How do we calculate that? Right? What do you think?
You're gonna do C channel.
C channels, yeah. What do you think of this? Does this how would you interpret that?
Or number of channel slice up the
Ju-
channel.
Just think of this, right? First iteration, C is what? 0, right? Which channel is it? Red, right? R. Okay. So you're in the R's. That's all you want. Okay. So you go into batch and you grab zeros, all the reds. Do you guys see that? And then because this is the second one, you just tell it here that you want all. And of course, it's implied that it's all for all the other ones as well, as we did before. You guys get it? So this is the trick, right? So you slice for that channel, and now of that data, you take the mean and you store it in here. You repeat the standard deviation, is pretty much the same thing because it's the same computation. You do it for the reds. Now you repeat it, second iteration, 1, index is 1, C is 1. What does that mean? It is no longer the red, but it is now the green. So now slice the greens, and for all of them, get the mean and the standard deviation. And then you do it RGB. So you have it for the blues as well. Make sense? So now you have the mean and the standard deviation. And now the question is, the trick is, you have them here, right? Mean and standard. But you need to now apply the operation to the correct image and assign it back to the batch. So basically it's like they're there and normalize. So how do you do it? All right, so where? In this one? Both batches, okay. Yeah. Okay, and then what? It's definitely a slicing, right? So what do we slice?
The first,
So the first option is what?
it's the number, or the batch number.
Well, the only thing we have to be careful with here is that we're keeping the channels aligned. That's the trick. So we only want to do in the second one the R, the G, or the B. So it's the same idea, right? So that kind of means then something like this. Would that work? Because you're taking now what? What is that here? It means you're grabbing all the images, right? But only the red ones. And whatever the value was before, like 129, 255, but now that particular pixel is 255 minus mean divided by standard deviation. And that gets assigned to the value. You see that? And so that's a normalization on a tensor level basis. This is hard. Okay, I'm not saying this is easy. This is the kind of thing that you need to sit down, pencil and paper, create a tensor that's much smaller with actual numbers, work it out. And then once you know it does the calculation that you want, scale it back up again. That's my recommendation whenever you encounter something like this. That's why it's really important to be able to, on the fly, create little tensors. You know, in your Jupyter, when you're doing something like this, you find something, add a little like section. Okay, I'm going to try my little tensor here with these values, print them out, work out the math until you get the value that you want. You can do it with tiny numbers, tiny dimensions, and then just scale it up and you'll know it works. This is probably the only way. I don't know anyone that I mean, some gifted people may do it on their heads, but I certainly don't. So, okay. These are the kinds of things where you have to work it out by hand. Or with smaller tensors. And real values. Got it? All right, so yeah, so I think that kind of let me just let's print it, right? So we updated it, hopefully. So now let's take a look at, let's run it. Did an error out, so that's a good sign. And then let's just copy this one again, and let's hope that they're normalized. Oh, it gave me an error actually. Okay, so it wants it to be a float. Right, that's what it said. So let's make batch equal batch dot float. These are things that happen in Torch sometimes. Okay. Yeah, that should have fixed it. So I just made the data type. I think it was integer, it's integer originally, right? So it just makes it float for it wants it for this operation. Okay. All right, so now if we repeat the other one, hopefully it is scaled. Would you say they're normalized? Now, keep in mind, a lot of the time you do have functions that do this for you, okay? But knowing or being able every now and then to do this from scratch is useful as well. Okay? Does that make sense, guys? Again, this is a hard one, but eventually I think some of these start to click in over time. All right, so it is 6:25. So let's take a 10-minute break, and then we will come back at 6:35 to wrap up the class. I do have to leave exactly at 7:50. But yeah, let's take a 10-minute break, and I'll stop the recording.